Okay, so the last question, we are told that Larry has set up a compound interest investment. So what that means is he's going to invest some money. It's going to earn interest every compounding period, and as well as that, he's going to make a payment to increase that balance. Okay, so let's have a look at the main points of the question. He's going to add $300 every month. The interest is going to be paid 4.25%, and we need to take note that's compounding monthly. And we're given the amortization table for the first 3 payments so that we can work some things out. So the first part of question A is determine the interest earned after 1 month. That is the value of A. So if we know the interest rate per annum, we can work out the interest rate per month, and we can multiply the balance by that amount. The other way that we can get this value is by understanding the amortization table, and by understanding that if $387.50 has been added at the end of that payment, 300 of that came from Larry, and we can actually take away 300 from 387.50, and that will also give us the interest earned. So let's look at this 2 ways, just to prove to yourself how it can be done. So we can say 387.50 minus 300, and that will give us a value of A of $87.50. And that's a perfectly good way to work out that amount. We can double check that if we have a look at multiplying the balance by the monthly interest rate. So the monthly interest rate would be 5.25 divided by 12 divided by 100. Okay, and then we'd multiply that by 20,000. That would also give us $87.50. I think the first way is easier, but you need to understand how the table works if you're going to use that method. Part 2 of A, we're asked the balance of the investment after 3 months. Okay, so this value of B. And all we need to do there is just add the principal addition to the previous balance. So we'll have 20776.7 plus 390.90. Okay, so that will be the balance of our investment after 3 months. Okay, so Larry's employee is expected to retire in 15 years, and we're going to use the finance solver to determine the amount that will be paid upon retirement. So we're just looking for our FV value given everything we've already been told. Now let's work out first 15 years how many months that will be. So we'll have 15 times 12. Okay, so we're looking at 180 months. Going now into the finance solver. So 180, the interest is 5.25 per annum. And really we, we've got 20,000. Okay. And every month he's adding to that investment, which is at the bank, so it's going to be negative. Better change our compounding periods. Okay, and we're looking for the future value. So let's hit enter. So the last part of the question C, we're told that after 10 years, Larry decides to increase the monthly payment and he wants to have his employee retire with $150,000. So we're actually going to have to do this part of the question in 2 steps. We need to find out what our future value is at 10 years. And then we need to decide what will be a new payment to end up with a total future value of $150,000, which would be at the 15-year mark. So let's start, do the first step. So the first thing we need to do is go back into our finance solver, and we're going to change our end value to 10 years, so 12 times 10, so 120. Okay, and let's work out what the future value would be in 10 years. And we're told it's $80,983.57. Okay, so now we're going to actually take this payment, this FE, and make it the new PV in the next part of the question. All right, so we've got 5 years remaining. So we've found out the value at 10 years. There's another 5 years, so 5 times 12, which will be 60. And it's almost like he's starting a whole new annuity investment. So we're going to put in that new PV, negative 80983.57. And he wants the final value to be 150,000. And we're looking at what payment will make that possible. So we hit enter on payment, and we're told that his new payment will have to be $654.09.